For this system, this one's a little bit easier than the last one. First thing, both of these, right, both of these have mass m, so m and m. And the first thing they ask us for is to find the rotational inertia of this system. So basically, this is just 2 point masses, and this is our axis of rotation. The rotational inertia of a point mass is mr squared. So the rotational inertia of this system is just going to be the sum of the rotational inertia of 2 point masses. So it'll just be ml1 squared plus ml2 squared. And since the rod has negligible mass, we don't even need to include it. Now the second part, we need to find the net torque on the system. So we need to pick a positive direction. I'm going to go ahead and just call into the page positive because we know that the rod is going to want to twist that way, right? If we let it go, if this is the axis of rotation, it's gonna start to rotate in the clockwise direction. So we're going to call into the page that way positive. So what that means is that this mass is going to cause positive torque, the other mass is going to cause negative torque, and torque is just Rf. But we've got to look at the combination of torque from the two. So the mass on the right will cause torque equal to mL2, and the mass on the left is going to cause negative torque equal to mL1. Now the last part, they're just asking us for the angular acceleration. We know the equation we ought to use is Newton's second law for rotation, so net torque equals I alpha. And we just found the net torque. It was mL2 minus mL1. And if we want to find alpha, we're basically going to have to divide this net torque by what we just found for the rotational inertia, which was mL1 squared plus mL2 squared. And this all was equal to alpha. Now notice here, right, since m is in every term, we can effectively just cancel it out. So our final equation for alpha, it doesn't even depend on the mass. It only depends on those lengths. L2 over L1 divided by L1 squared plus L2 squared. That is going to be our alpha. All right.